Hello, this is 1-1 classification of numbers. Today's topic is fairly simple. All you need is a simple diagram and some basic knowledge of what we're learning today. And then you can use these notes, which you will copy into your notebook, and hopefully get perfect score on your homework. So here the diagram is. So here is a small circle, area we call imaginary. And these are our imaginary numbers. I would assume that you don't know any. All the numbers you know so far fall into this big category known as real. So all the numbers you've known your entire life, like 1, 2, 2.5, negative 10, negative 10.5, pi, those are all real numbers. And within real, there are two little subcategories. One is rational, and one is irrational. We'll talk a bit more about their definitions later. Within rational, there is another called integer. I'll also teach about how to decipher what this diagram means. And within integer, there's another called a whole. And within the whole, natural. So make sure you have this in your notes. Make sure you can you have all this down. You can pause the video to copy this into your notes. Alright, now we're going to talk about each of their definitions and what each of them mean. Alright, so first we're going to talk about real versus imaginary. You can copy their definitions into your notes. So real, you can think of it as any number that can be put on the number line. So, for example, say we had a number line 0 can be put on the number line. It's a real number. 10 is also a real number. It can be put on the number line. Pi is also a real number. We know that it's somewhere between 3 and 4, specifically in between 3.14 and 3.15, or so on. You can be even more specific, but it's on the number line somewhere, about here maybe. What about imaginary? Imaginary numbers are numbers that can't. I won't copy this down, but you can just or actually, whatever. Any number that can't be put on the number line. You don't know any imaginary numbers so far, but I will introduce the number I. You don't need to know much about I right now. All you need to know is that I is an imaginary number. We will talk a bit about this in future topics, but for now, all you need to know is the only imaginary number that you ever encounter so far in this course is I. So just you can copy it down. Imaginary number is any number that cannot be put on the number line, and you can put like quotation marks or parentheses and have I in it to remind yourself that I is the only imaginary number that you will encounter in this course. And of course, real is any number that isn't imaginary. So all the numbers you've ever known. Also, if you can see from the diagram, you'll realize that real and imaginary do not overlap, meaning that any number that is real is not imaginary and vice versa. So any imaginary number is not real. It can only be one of either. And something that I do not illustrate well in the diagram is that a number is either real or imaginary. So that too. All right. So now we'll erase that. And again, if you don't have all this in your notes, make sure to go back and copy it down so you have it in your notes for the homework, etc. All right. Next, we're going to talk about rational versus irrational. So within real, there are two types of numbers, rational and irrational. Rational is any number that can be written as a fraction. So any number basically that can be written as a fraction is rational. So for example, 3. 3 is a rational number. You can write it as 3 over 1, 6 over 2, 9 over 3, like that. 1 over 3, so 1/3, is also rational. 1/3 is a fraction, right? Any number that can be written as a fraction. 0 is a rational number. That's 0 over 1, right? Negative numbers are also rational. For example, -1, -1 over 1, right? Irrational numbers are any number that can't be written as a fraction. So far, the only irrational number that you may have been introduced to is pi. This is the only irrational number. Sure, you might know of some repeating numbers, but most of them can be rational. So, for example, 1/3, again, is rational because it can be written as a fraction, 1 over 3. So you can also put in parentheses that the only irrational number that you probably will encounter so far, other than we might talk about roots later, the parentheses pi, because pi is the only irrational number that you will encounter in this homework assignment. So put that in a parentheses next to the definition. All right. All right. The next couple of things we're going to talk about are integers, whole numbers, and natural numbers. So integers are any number that can be written without decimals. Whole numbers are any integers, including 0, that are positive. And natural numbers are any whole number not including 0. So they might be a bit sloppy, but you can you can hear it and you can write it down. So I'll explain this now. Integers are all numbers that can be written without decimals. So for example, -10 is an integer. -2.5 is not an integer because it has that 0.5. -10 over 2, that's an integer because that's -5. And so on. Now 5 is also an integer. Whole numbers are any integers including 0 that are positive. So for example, -5 would not be a whole number. It is an integer because it doesn't have a decimal point, but it's not a whole number because it's negative. So -5 is not, but 1 is a whole number. 10 is a whole number. 15 is a whole number. 100 is also a whole number. Natural numbers are basically whole numbers, but 0 is not a natural number. So the only thing distinguishing these two is whether or not 0 is part of them. So basically, all numbers that are natural are also whole, except 0. So all whole numbers are natural numbers except 0. So the set of whole numbers is 0, 1, 2, so on. Natural numbers starts the smallest natural number is 1, and then 2, 3, 4, so on. So again, all natural numbers are whole numbers. All whole numbers are integers, as you can see in the diagram, right? The natural circle, the area, is inside the whole number area. Entirely. The entirety of the natural circle is inside the entirety of the whole circle, which means that all natural numbers are also whole numbers. And if you also see the entirety of the whole area is also part of the integer area, which means that all whole numbers are also integers. And also all integers are rational, according to the diagram. All right. Now we're going to have some practice. So I want you to classify the number 10. What is it? I want you to tell me all the ones that you know. You could pause the video and, yeah. Alright, assuming that you've paused the video and completed this question, 10 obviously is a real number. It's not imaginary because it's real. It can only be one of the two. It's also rational because it can be written as a fraction, 10 over 1. Since it's rational, it's not irrational. It can only be one of the two. On top of being rational, it's also an integer because it doesn't have a decimal point. And on top of being an integer, it's also a whole number because it's a positive integer. And on top of being a whole number, it is also a natural number because all whole numbers are natural numbers excluding 0, and 10 is a whole number and is not 0. So it's all 5 of these. So on the homework assignment, make sure to select all that apply. Alright. Next, we'll have -5. I want you to tell me all of the categories that it falls under. I'll give you a moment to pause the video and do the question. Alright, assuming that you've paused the video and done the question, here's the answer. Obviously, -5 is a real number. It can be put on the number line. It's in between -6 and -4. Since it's real, it's not imaginary. It's also rational because it can be written as a fraction, -5 over 1, -10 over 2, and so on. It's also an integer because it doesn't have a decimal point. Again, it also cannot be irrational because it's already rational. It can only be one of the two. And that's it. That's all -5 is. It's not a whole number because it's negative. It's not a natural number because it's negative. So these are the categories that it falls under. I don't think I'm missing anything. Alright. We'll do a couple more, and then we'll end today's class. What about 0? This is on the homework, so I want you to pay attention. Do it yourself. We'll give you a couple seconds to pause the video and do the question. Alright, again, assuming that you've done the question, here's the solution. So 0 obviously is a real number. It can be put on the number line. It's in between -1 and 1, right? Since it's real, it's not imaginary. 0 is also a rational number because it can be written as a fraction, 0 over 1, or 0 over 2, or 0 over 100. They're all equal to 0. On top of being rational, it is also an integer. Again, integers are all numbers without decimal points, and 0 does not have a decimal point. Alright. On top of being an integer, it is a whole number. And because whole numbers include 0. However, that's where it stops. It is not a natural number because natural numbers do not include 0. So these are what 0 are. Alright, we'll do one last question. Pi. I want you to answer this question. What is pi? What categories does pi fall under? You can pause the video and do the question yourself. Alright, again, assuming that you've done the question, which you definitely should, it's extra practice. Here is the answer. Pi is real. Believe it or not, we talked about this before. Pi can be put on the number line. It's a bit after 3.14. It's also a irrational number because it cannot be written as a fraction. You can't do pi over 1. That does not count. Pi cannot be written as a fraction. It's a non-terminating number, which means that it does not end, right? It's 3.14159. It does not stop. And it also does not repeat. So unlike, for example, 1/3, which is 1.33333, all repeating, so 1.3 repeating, it goes on 3 forever. Pi does not do that. It has basically random jumbles of numbers that go on forever. So it stops there. Why? Because, again, according to the diagram, if it's real and it's irrational, there's nothing in the irrational box, which means that if it's irrational, no way can it be rational, an integer, whole number, or natural number. So if you need something that does not fit a little box, a little circle, anything inside the circle, it's also not. So that's additional tip for the homework assignment. So that's it for this class. I hope you learned something. Homework is due on Friday. And yeah, I'll see you during 1.2, which will be the next class.